Hello everyone, welcome for this session. Today we are going to continue with the same numericals on symmetrical components. Okay, it's a bit different. That's what I'm taking a video on this. Right. So today we'll see the numerical in a three-phase system. IA1 is 100 at an angle 30 degree ampere. IB2 is 40 at an angle 90. And IC0 is 10 at an angle minus 30 amperes. Find the line currents. Okay, meaning of this one is they have mentioned symmetrical components. Observe IA1 is a positive sequence, IB2 is a negative sequence, and IC0 is a zero sequence. Okay, they have mentioned positive sequence, negative sequence, and zero sequence. Observe they have given IA1, IB2, IC0. Okay, let's see. As we know, we need to calculate a line currents, that is IA, IB, IC, which is equal to this formula we know, right? 1 A square A, 1 A square into IA0, IA1, IA2. IA0 means zero sequence, IA1 is positive sequence, IA2 is negative sequence. Just observe these things they have given, right? But how they have given, you just check. IA1 means positive sequence, so they have given IA1. IB2 they have given, but they have not mentioned IA2. Okay, just remember. And then next IC0 they have given, they have not given IA2. Means each phase one values they have given, but we require all phases of A component only, A phase only, right? IA0, IA1, IA2. Therefore, we need to check. So means we need to convert all this in this form first. IA0, IA1, IA2. So first IA0. So they have not given IA0. Okay, first we need to calculate that. Next IA1 we require. So yes, they have given it as 100 at an angle 30. Right? This one they have given. And next IA2 we require, but they have given in the form of IB2. But these two are not equal. Okay, we need to convert and calculate. Okay, task is only thing is first we need to get IA0, IA1 and IA2. Anyhow they have mentioned this IA0 and IA2. If you know, then substitute in this IA, IB, IC, you will get it. Okay, let's say first we'll do IA0, that is zero sequence. Recall once, in a zero sequence, all phases are of same magnitude with a zero phase angle. Okay, meaning of this one is all are same, right? IA0, IB0, IC0. So IA0 is nothing but your IB0, IB0 is nothing but your IC0. Therefore, you know IC0, that is nothing but your IA0, right? IA0 is nothing but IC0 only. That is how much they have mentioned. It is of 10 at an angle minus 30. Okay, yes, we have got another one, right? Now we need to take IA2, that is negative sequence. Recall once, negative sequence component, that will be opposite to the positive sequence. Okay, ABC is a positive sequence, then ACB is your negative sequence. Okay, draw that. It is A, C, and then it is B. Okay, it is A, it is C, and it is B, each of 120 degree. Okay, each of 120 degree. Obviously this is IA2, IC2, and this is IB2. Okay, now which one you know and which you are going to calculate, that you be careful about it. Okay, so observe, now you know IB2. Okay, you know IB2, you need to calculate what is IA2. Okay, I repeat once, you know IB2, you need to calculate IA2, and you be here. Okay, you be here, that is IA2 is equal to what? Okay, magnitude remains same, and that is IB2. Okay, just look back. Okay, just look back, right? You are moving in anti-clockwise direction, so just look back. What value you know? IB2 value you know, and how much leading you require to reach IA2, that is of 120 degree plus 120 degree, that is 240 degree. Okay, and then if you don't confuse, I'll explain one more thing, that is in earlier cases we used to calculate what is the IB2 is. Okay, we need to calculate what is IB2. That time you are knowing IA2 value. Okay, IA2 value. So you have to stand here look back. Okay, and then what is coming? IA2 is coming. To lead that, how much it is? At 120 degree. Right? Now this is holds good. This one holds good in earlier cases. Right? So now we are not taking this one. Right? IA2 is equal to IB2 as magnitude, and it is 240 degree leading. Okay, if you lead this much, you get a IA2. Okay, and you know IB2 value, right? You know IB2 value. Substitute it and get the values. Now we'll write what is the IA1, IA is IA0 and all. Okay, IA0 is same as that of your IC0. That is nothing but 10 at an angle minus 30 amperes. Okay, and then IA1, you know, that is already they have mentioned. IA1 is 100 at an angle 30 degree, this much amperes. Then IA2 is nothing but IB2 into 1 at an angle 240 degree. Okay, so then IB2 is how much? It is 40 at an angle 90 into 1 at an angle 240 is nothing but a square into 40 at an angle 90 degree. Right? So this much you know. Now you calculate what is IA, IB and IC, which is equal to, just expand this, okay, and then calculate. That is IA is equal to IA0 plus, note down here and then write IA is equal to IA0 plus IA1 plus IA2. So IA0, IA1 plus IA2. Okay, and then IB is equal to, you know the values, and substitute and get the values. IA0 is 10 at an angle minus 30 plus 100 at an angle 30. Next, IB2 is, just write, it is 40 at an angle 90 into 1 at an angle 240. Okay, then get the values of this one. Okay, it is nothing but 132.24 at an angle 10.89 amperes. Okay, calculate and check it. So IB is equal to what? IB is equal to IA0 plus A square IA1 plus A into IA2. Okay, so just it is IA1, right? IA0 10 at an angle minus 30 plus A square is 1 at an angle 240, right? Into IA1 is 100 at an angle 30. Okay, plus A into 1 at an angle 120 into IA2 is how much? 40 at an angle 90 into 1 at an angle 240. Okay, so just do this one. You get IB is equal to, you get a 65.57 at an angle minus 82.4 amperes. Like similarly, IC is equal to, just go through this multiplication. That is IA0 plus A into IA1 plus A square into IA2. So substitute all the values. IA0 is 10 at an angle minus 30 plus A into 1 at an angle 120 into IA1 is 100 at an angle 30 degree plus A square, that is 1 at an angle 240 into IA2. IA2 is 40 at an angle 90 into 1 at an angle 240. Okay, then if you do this, you will get 115.32 at an angle 167.48 amperes. Okay, therefore IA, IB, IC, they have given symmetrical components. We need to calculate line currents, so we have calculated. Okay, thank you.